Okay, the last big topic in graph theory that we're going to cover in this class has to do with directed graphs. So we've talked about coloring maps. We did that in lecture 30. We've talked about weighted graphs. We did that in lecture 31. We talked about graphs where you have multiple edges or possibly no edges connecting 2 points and stuff. Again, that was lecture 30. What we're going to do here with directed graphs is we're going to talk about when you have relationships that don't go two ways, then we represent those with directed graphs, right? So what I mean by that is this. Some relationships go two ways. If you live on the same street as Katy Perry, then Katy Perry lives on the same street as you, right? So that's a two-way relationship. But other relationships are one-dimensional, right? So if Rose is the mother of Rosita, then Rosita is definitely not the mother of Rose. Okay? So if you're trying to come up with a graph of motherhood relationships, right? Then the relationship between Rose and Rosita would only be one directional. Okay? So far we've used graphs for two-dimensional relationships. For one-directional relationships, we need to give each edge a direction. So with two-directional relationships, it's easy because you just draw an edge and it's assumed that you could go in either direction along the edge. If the relationship is one-directional, however, then you need to state which direction you're allowed to move in as you traverse the edge. So when an edge has a direction, it's called a directed edge. And a graph in which all edges are directed is called a directed graph. So for example, let's assume that we have gathered the following information about how rumors spread in the Pritchett family. Okay, so if Manny hears a rumor, he will communicate it to Gloria and Jay. So he's a little gossip, I guess. But Gloria and Jay will not tell rumors they hear to Manny. Well, yeah, that's because he's going to spread the rumor. Anyway. Okay, so if Manny hears a rumor, he'll tell it to Gloria and Jay, but Gloria and Jay will not tell rumors to Manny. Gloria and Jay will, however, tell rumors to each other. And then finally, Gloria tells rumors that she hears to Cameron, but Cameron does not relay rumors that he hears to Gloria. He does, however, relay rumors he hears to Jay. Okay, so let's see if we can model the situation with a directed graph. We've got Manny, Gloria, Jay, and Cameron. Okay, Manny definitely communicates to Gloria and Jay. But they don't communicate to him, so these are one-directional. Right? They flow from Manny to Gloria and from Manny to Jay. Okay, number 2. Gloria and Jay will tell rumors they hear to each other. So Gloria and Jay communicate. And since we're drawing a directed graph, if I just draw an edge like this without indicating a direction, that's a little confusing. So what I'll do is I'll draw 2 edges actually. One of them going from Gloria to Jay, the other one going from Jay to Gloria, since they communicate with each other. Okay? Gloria tells rumors to Cameron, but Cameron does not tell rumors to Gloria. So there's a line here that goes from Gloria to Cameron, but not the other way around. However, Cameron does relay rumors that he hears to Jay. So Cameron will talk to Jay. Jay, however, does not talk to Cameron. But Jay talks to Gloria, who talks to Cameron, so I guess, And by that token, I guess Manny talks to Jay, who talks to Gloria, who talks to Cameron. Or he talks to Gloria, who talks to... whatever. Anyway, that's that. Okay, so that's what that directed graph would look like. Okay. Suppose that x and y are vertices in a directed graph. If it's possible to begin at x, follow a sequence of edges in the directions indicated, and end at y, then we call the sequence of edges a directed path from x to y. The length of the directed path is the number of edges along that path, of course, and recall, as usual, edges cannot be repeated in the path. For example, let's consider the directed graph here. What's the length of the directed path ACDE? ACDE. Okay, yeah, so we're flowing in the right direction. ACDE. How many edges are there? 1, 2, 3. So the length is 3. Okay. Is ABCE a directed path? Well, let's see. We can get from A to B. We can get from B to C. We can get, well, we can't get from C to E, right? Because that would require us to travel in the opposite direction that we're supposed to travel along this edge. Now you could say, oh, but couldn't you go to D and then E? The answer is yes, but that's not the path that was given to us. We were given A, B, C, E, not A, B, C, D, E, which would be legitimate. But this one's not legitimate. The answer is no. Going from C to E in the wrong direction. Okay, that's that. So now let me give you a couple of examples of how this idea can be applied. And by the way, I've already fixed this in your notes. I just deleted some of the instructions because I think they were unnecessary and maybe a little bit confusing. So this says, Big Mart wants to build a shopping center and is receiving opposition from the residents of Peaceful Town. Big Mart's lawyers suggest that the best approach is to get approval for the project, Big Mart's lawyers suggest that the best approach to get approval for the project is to gather the support of the most influential members of the zoning board. After careful investigation, Big Mart's lawyers determined the patterns of influence listed in the table below. So Alvarez has influence over Cohen, Ellis, and Ferraro. Baker has influence over Ferraro. Cohen has influence over Baker and Ellis, and so forth, right? We're supposed to determine which board member has the most influence. Well, just at first glance, looking at this chart, it seems like, well, Alvarez has influence over 3 people. Davis also has influence over 3 people. Everyone else only has influence over 1 or 2 people. So you might think, well, Davis and Alvarez are tied. They're tied. They have an equal amount of influence. But we can analyze this a little bit more carefully, right? It's true that they have an equal amount of direct influence, right? They both have direct influence over 3 people. But we could ask ourselves, what about secondary influence, right? Like if Alvarez influences Cohen and Cohen influences both Baker and Ellis, right? Then Alvarez has like a second-hand influence over, say, Baker, who he doesn't have a direct influence over. But through Cohen, he has a second-hand influence. And we could say similar things about Davis's list. So maybe when you add in the second-hand influence into the mix, we're able to come up with a clear winner for who has the most influence, right? So, so my strategy here is going to be, first of all, to draw a directed graph showing the direct influence. And then what I'll do is I'll total up for each individual. I'll total up how much direct and second-hand influence they have, in the hopes that I'll be able to come up with a clear winner. Okay, and the way that that'll relate to my graph is that it's going to be any directed path of length 1 or 2, right? Okay, so let's draw the graph. Fortunately, these people all have names A, B, C, D, E, F, which is really convenient for me. So how to lay these out? I mean, these are complicated structures. I did some work on this earlier, so I'm going to copy down what I did from before just to get a nice, clear-looking graph. You could kind of play around with it yourself to maybe come up with something you like better, I suppose. So this is A. I'm going to put F down here. I'm going to put C here, and then E, and then D, and then B. So this is D, this is B, C, and E. Okay, so let's see. A has direct influence over C, E, and F. So those are all going in that direction. B has influence over F. C has influence over B. And over E. D has influence over B, C, and E. E has influence over B, and F has influence over C and E. Okay, so there's the graph that I'm coming up with. Now again, what I want to do is figure out the total amount of influence, first and second hand influence that each council member has over every other council member. And so the way that I'm going to organize my information is into a chart, right? Like this. A, B, C, D, E, F, and A, B, C, D, E, and F. Okay, and might help to have these all separated out. And then I'm going to have a total. Okay, so let's see if we can do this. I'm going to use pencil in case I make a mistake. Okay, so the way that we would fill this chart, we would ask ourselves, does A have influence over A? And the answer is, well, I mean, it's the same person, so it doesn't really make sense. We're just going to put a 0 for that. Does A have influence over B? And if so, in how many ways? So let's see. Does A have influence? Well, A doesn't have direct influence over B, but maybe it has second-hand influence over B. For example, I could get from A to C, and then from C to B. So that's one way that it has second-hand influence. I could also get from A to E and from E to B. So that's another way. So 2 ways so far. Or I could go from A to F, but I can't get from F to B, right? It goes in the wrong direction. So I think there are 2 ways that A has influence over B. All right. Does A have influence over C? Well, yeah, it has direct influence that way. Does it have second-hand influence? It could go from A to E, but it can't get from E to C. It could go from A to F and from F to C. So yes, so it has direct influence this way and second-hand influence that way. So two ways that it has influence over C. Does A have influence over D? No direct influence. Does it have second hand? Well, I could get from A to F and F to C or E. So no. I could get from A to C, and from C I can't get to D. Doesn't look like it. Or I could get from A to E, but I can't get to D. Shoot. So no influence over D. Not, or at least they might have tertiary influence, right, or something like that, but they don't have first or second degree influence. What about over E? Yeah, direct influence over E, so there's one way. Secondary influence from C to E, so that's two. Then it could get from A to F, but not, so three ways. Right, so three ways that A has influence over E. What about F? Well, direct influence, for sure. No secondary influence from A to C. A to E, no. So there's just one way. All right, so the total amount of direct and secondary influence that Alvarez has is 2 plus 2 plus 3 plus 1. So that's 4, 5, 6, 7, 8. Okay. Now, I'm not going to take you through all the nitty-gritty of this entire chart. I just want to fill out one more row so that you can see how this goes. And then I'll pause the video and fill in the rest of the numbers for you so that you don't have to sit here and watch me do all this. But, okay, so for B, does B have influence over A? No direct influence, right? B only goes to F. That's the only direct influence B has. But what about secondary influence? We could go from B to F to E, or from B to F to C, and that's it. So it never gets to A. Doesn't make sense to talk about having influence over yourself. Can B get to C? Yep, it can go from F to C. That's the only way, though. Can it get to D? No. Can it get to E? Yes. Here and then there. Can it get to F? Yes, directly. So the total amount of influence that Baker has is 3. All right? That one was kind of easy. Maybe we'll do another one. Let's do another one together, and then I'll pause and do the rest. So for C, can C get to A? Not directly. Maybe in a secondary way. C can get to E, but E can't get to A. C can get to B, but B can't get to A. So I don't think C has influence over A. C does have influence over B directly. Does it have secondary influence? Yeah, it can get from E and then to B. So it has two ways to get to B. Doesn't make sense for C to influence itself, I guess. C to D. C can get to, it can't get directly to D. It could get to E, but then not directly to D from there. It can get to B, but not to, so no. Okay. Can C get to E? Yes, it can get there that way. Can it get there by a secondary route? It can get to B, but no. So just one. Can it get to F? Not directly, but it can go from C to B and then B to F. So yes, in a secondary way. So C has a total influence score of 4, right? So that's kind of how this works. Let me fill in the rest of the chart. Okay. So I filled in the rest of the chart, and this is what you get. So we do have a clear winner, right? So again, if we count up just the direct influence, we have a tie. But if we count up direct and secondary influence, well, then we have a clear winner, Alvarez. Alvarez is more influential than Davis, okay? So Alvarez is the winner. Okay? So Alvarez has the most influence. Alvarez has the most influence. Who has the least? Ellis. Ellis has the least influence, right? Ellis has the least. In case you were interested. But yeah, Alvarez has the most influence. So Big Mart, their team of lawyers, they're gonna like make Alvarez an offer he can't refuse, and then he's gonna influence all of the other board members, and evil. Anyway, that's that. Okay. So one more example. This one is very sort of important, I guess, for what we're currently living through. It says, a scientist at the CDC has quarantined 8 members of Doctors Without Borders who have come down with symptoms of the deadly Ebola virus. Only we're not dealing with the Ebola virus right now, we're dealing with COVID, right? Anyway, she hopes that no others outside of this group have contracted the disease. She believes that one person contracted the virus and transmitted it to the others in the group. Use the information in the table below to determine if her hypothesis is correct. So she thinks that one of the people in this group... by the way, when I was making this chart, I accidentally left off Brian, so I added it on, but I've already fixed that for your version. So for your version, you should have a line between Amanda and Katerina that has Brian in it. But anyway, but yeah, so her hypothesis is that one of these people got it and gave it to everyone else in the group. Is it possible? Is that possible? Is that a feasible explanation? Well, let's see. So again, I just did some work ahead of time to try to figure out a good way to lay out the graph so that it was as unconfusing as possible. Okay, and so here's what I came up with. You might come up with something you like better. Okay, so I've got A, B, C, D. There was no E, but there was a Frank, an Ina, a Jackson, and a Louisa. Okay. And the connections are as follows. So Amanda could have gotten, or others in the group who could have gotten, so Amanda could have given the virus to Dustin or Jackson. Katerina could have given, or maybe I'll do Brian next. Brian could have given the virus to Katerina, or to Frank, or to Ina. Katerina could have given the virus to Frank. Dustin could have given the virus to Katerina. Frank could have given the virus to Louisa. Ina could have given the virus to either Brian or to Frank. Jackson could have given the virus to Amanda or to Katerina, or to Frank. And Louisa could have given the virus to Katerina. Okay, so this is what's known. Maybe they did some kind of like tracking system or whatever to see who was in contact with whom. And this is what was determined, right? Okay. So the question we're wanting to answer is it possible for one person in this group to have given the virus to everyone else in the group? Like, not necessarily directly, but like in a secondary or tertiary path. Well, if they did, then there would have to be a directed path from one person to everyone else in the group. So for example, right, is it possible that the virus originated with Amanda? Well, if it is possible that the virus originated with Amanda, then there would have to be a way from the virus to get from Amanda to Brian. Now, is that possible? Well, let's see. Maybe it went up this way and then over this way. But it can't get to Brian that way, so maybe it goes up. And then, it has no choice but to go this way and then back this way. And then I just end up in this never-ending loop. So that didn't work. So maybe it didn't go up. Maybe it went over this way. And then up that way. And then I end up with the same problem. Okay. So the answer is no. It's not possible for the virus to get from Amanda to Brian. So the virus could not possibly have started with Amanda. Is it possible the virus started with Brian? Well, let's see. If the virus started with Brian, there would have to be a directed path going from Brian back to Amanda. Is there? Let's see. We could get from Brian to Katerina, and then for Katerina, we end up in this never-ending loop. So I kind of want to avoid Katerina. Maybe I can go from Brian to Ina over to Frank. Once I get to Frank, though, I end up in this Katerina vortex. So it doesn't appear to be possible for the virus to have started with Brian and gotten to Amanda. Okay, so Amanda couldn't have started it, Brian couldn't have started it. Could Katerina have started it? Absolutely not. Katerina couldn't have started it, right? Because there's no way for it to get from Katerina to Brian. Okay, could Frank have started it? No. Frank is caught in the same vortex as Katerina, so Frank couldn't have started. There's no way for it to get from Frank to Ina, for example, or from Frank to Jackson. So Frank couldn't have started it. Could Ina have started it? Ina. Well, Ina could go to Brian and then back to herself, which would be kind of useless. But Ina to Brian, maybe over to Frank, and then we're stuck. Or Ina straight to Frank, and then we're stuck immediately. So it doesn't appear like it could have started with Ina. Could it have started with Jackson? Let's see. Jackson has a few options, right? Jackson may have gone to Amanda, and then over to Dustin, and then over to no, that's not gonna. If I get to Katerina, it's gonna end up in a loop. Maybe he went up instead. He went up to Frank. But if he goes up to Frank, then he still gets stuck in a loop. There's no way to get from Jackson could take care of A, D, C, F, and L. He could take care of all of these people, but there's no way for Jackson to account for how Ina got it or how Brian got it. So Jackson doesn't explain the full picture. What about Louisa? Could Louisa have started it? Nah, she's caught in this same vortex as Katerina and Frank. Okay, so the answer to the question is no, her hypothesis is not correct. According to the information we have, there's no way for the virus to get from any one person to all of the other people in the group. So there must have been more than one point of entry, right? There must have been there must have been two different people in the group who got it, or maybe there's another person who hasn't been quarantined yet who gave it to all of these people, right? But one of these people didn't give it to everyone else. Not possible. So no, our hypothesis is not correct. Okay, there's a train coming, but that's the end of that example anyway. There's not a lot of writing. You just have to kind of think through the whole thing to come up with that conclusion. But that's that. I'm going to end it there.